A lot of IDP projects fail for a simple reason. Teams think reading the document is the hard part. It is not. The hard part is everything after extraction: validation, routing, review, and making the output usable in real enterprise workflows. Serious enterprise IDP does not begin with OCR. It begins with intake and job registration. That step sounds administrative, but it is one of the most important parts of the system because it defines what is being processed, where it came from, what the organization already knows, and what should happen next. A weak design starts with a file dropped into a folder and a service that tries to guess everything from the document alone. A stronger design starts with a job contract. That contract may include the caller identity, job type, source system, priority, timestamps, expected document family, and any metadata the upstream system already has. That matters because, in many cases, it is better to verify than to deduce. Take a practical example. Suppose a system receives a driver's license image. If the upstream workflow already knows the expected person name, state, or workflow context, the IDP system should use that information. The goal is not to make the model guess heroically. The goal is to validate the document against known context and reduce ambiguity early. Job registration also creates the control plane for the workflow. It gives the system a job identifier, a status, a place to store progress, a way to track retries, and a foundation for auditability. That is what allows teams to answer basic but critical questions. What is queued? What is running? What failed? What completed? What is waiting for review? Without that structure, the system is harder to monitor, harder to recover, and harder to support. This is the first big enterprise lesson. IDP is not just a document reading problem. It is a managed workflow problem. So when I look at enterprise IDP, I want intake to be deliberate. I want explicit job registration, known states, traceability, and enough metadata to avoid unnecessary guessing. That is how the rest of the pipeline becomes more reliable. Once the job is registered, the system can move into primary extraction. This is the stage most people think of first. OCR reads printed text. Some systems also handle handwriting, audio transcription, translation, or barcode decoding. This stage is important, but it should be treated as one component in a larger workflow, not the whole solution. Cloud vendors are often very good at this layer. Azure and AWS both provide strong extraction capabilities, and for many use cases, OCR itself is relatively affordable. That is why I usually treat primary extraction as a service boundary. The system submits the content, retrieves the output, and then hands that output to the rest of the enterprise pipeline. A practical implementation pattern is to keep both the raw input and the extraction artifacts. That may include the original image or PDF, the extracted text, layout information, bounding boxes, page numbers, and barcode results. That evidence matters later. If a reviewer questions a field, or if a validation rule fails, or if an audit requires traceability, the system needs more than a final value. It needs to show how that value was derived. Here is where weak and strong designs diverge. A weak design says, we got text back from the OCR engine, save the fields and move on. A stronger design says, store the evidence, normalize the output, preserve confidence information, and make the data usable for the next stage. That second approach costs a little more effort up front, but it pays off in supportability. Primary extraction is necessary, but it is not enough. Enterprise IDP needs extraction to be accurate, consistent, and recoverable. If a job fails halfway through, the system should know where it was. If the provider throttles or errors, the job should retry cleanly. If the output is incomplete, the system should still preserve enough structure to continue the workflow intelligently. That is what makes extraction part of a system rather than an isolated feature. After primary extraction, the system still has to answer a more difficult question. What exactly is this document, and which fields matter for this job type? This is where many teams overspend. They assume every identification problem requires a premium classifier or a heavy AI layer. Sometimes that is true, but in many enterprise workflows, the job type, source system, metadata, anchor phrases, form numbers, or barcode values already narrow the possibilities significantly. In those cases, conventional logic can do more of the work than people expect. Suppose a workflow processes landfill receipts, onboarding forms, or a known set of internal documents. If the upstream system tells you the process type and the OCR output shows a recognizable form number or key phrase, you may not need an elaborate classification pipeline. You may just need deterministic rules plus a fallback path for ambiguity. Once the document type is known, the system can move into field extraction. That means identifying the specific values that matter: ticket number, date, time, account number, vendor name, total, driver identifier, or whatever the business process requires. But extracted values alone are not enough. You also need confidence and context. Confidence should never be treated as a magic number that automatically decides trust. It is a signal. In a strong design, that signal gets combined with field type, business criticality, and validation rules. An 85% confidence on a descriptive text field may be acceptable. The same confidence on a tax identifier, patient identifier, or financial amount may not be acceptable. This is the operational point. Confidence is useful only when it drives behavior. A good system uses confidence to guide review, prioritize attention, and decide which values can continue automatically and which need escalation. That is how field extraction becomes practical and supportable instead of just technically impressive. This is the stage where IDP starts becoming real business automation instead of just extraction. Once the system has candidate fields, it has to decide whether those fields are plausible, complete, and useful. That is validation. Validation begins with simple checks. Are required fields present? Does the date parse? Does a total make sense? Is a required signature present? Are related fields logically consistent? But stronger systems go further. They compare extracted values against metadata from the upstream workflow, known master data, external systems, and business rules. Let me use a simple example. If a calling system says the expected truck number is one value and the extracted receipt says something else, that is not just an OCR issue. That is a business discrepancy. Or consider a workflow where a driver's license is submitted for verification. If the extracted front of license identity does not align with barcode data on the back, that is a strong signal for review. The point is not just to read the data. The point is to assess whether it holds together. Enrichment extends that idea. Once the system has extracted and normalized a value, it can pull in reference data. A truck identifier can map to a registry. A procedure code can map to a description. A vendor identifier can map to a known supplier. A location code can map to a region or workflow owner. That extra context improves downstream usability and helps the business act on the result faster. A weak design stops at extraction. A stronger design asks, what do we now know, what do we still doubt, and what additional context can make this output more useful? Validation and enrichment are where document data starts becoming business data. That is also why many teams underscope IDP. They think the expensive part is OCR. In practice, the higher value part is often the logic that confirms, corrects, enriches, and stabilizes the extracted data before it moves on. Human review is not a sign that the system failed. In many enterprise workflows, it is a sign that the system was designed honestly. Real-world documents are messy. Some are incomplete. Some are damaged. Some are ambiguous. Some conflict with known data. Some contain values that are technically readable, but operationally suspicious. A mature IDP system does not pretend that every value can be trusted automatically. It creates a path for low confidence, high risk, or business critical cases to be reviewed efficiently by a person. The key word there is efficiently. Weak review workflows dump raw outputs into a generic queue and force staff to figure everything out manually. Strong review workflows show the document, the extracted fields, the confidence levels, the validation failures, and the source evidence in one place. They focus the reviewer's attention on what is uncertain or inconsistent. A practical pattern is color-coded review with evidence support. Fields with high confidence and no rule violations may need little attention. Fields with lower confidence, failed validations, or metadata conflicts get highlighted. The reviewer can correct values, confirm them, or escalate the case further. That creates a fast and defensible human-in-the-loop model. Exception handling is broader than just reviewer screens. It includes retriable failures, non-retriable failures, unsupported formats, timeouts, provider issues, and jobs that get stuck between states. A production-minded system needs defined outcomes for those cases. It needs queues, retries, lease expiration, and a clear state model so that jobs can recover safely. In Enterprise IDP, exceptions are not edge cases. They are part of the design. That is one of the biggest differences between demo systems and real systems. Real systems assume ambiguity will happen, and they build around it. Once the document has been extracted, validated, enriched, and reviewed as needed, the final job is not save the field somewhere. The final job is to produce structured output that the rest of the business can trust and use. That may mean writing normalized values into a database, sending an event to another system, updating an existing workflow, publishing to a queue, creating a review record, or triggering notifications. The output shape depends on the use case, but the principle is the same. The IDP system should not end with text. It should end with a business-ready result. A strong implementation pattern is to separate extracted values from verified values. That gives the system a clear distinction between what the engine proposed and what the business accepted. It also supports auditing. If someone asks later what was read, what was changed, who changed it, and why the downstream system acted on a particular value, the answer should be available. This is especially important in regulated or high accountability environments. Government workflows, financial operations, compliance processes, and claims-related systems often need full traceability. They need timestamps, statuses, retry history, review outcomes, and evidence of how the result moved through the workflow. A weak design treats output as a convenience. A stronger design treats output as a contract. It is typed, versioned, traceable, and intentionally routed. That is what allows downstream systems to depend on it. The output is where Enterprise IDP proves whether it is useful. If the result cannot be trusted, integrated, and explained, then the system has not finished the job. But if the result is structured, validated, auditable, and routed correctly, then document-heavy workflows stop being isolated clerical activities and start becoming reliable parts of the enterprise operating model. Enterprise IDP works when it moves beyond extraction and becomes a controlled workflow for validation, review, routing, and usable output. Done well, it turns documents into reliable business data and gives organizations a practical foundation for broader applied AI. Explore more practical, applied enterprise AI insights at ain.net.com. Thanks for watching.